We have question 12, and a really nice question because it just brings the whole topic together. Okay, nothing new here, nothing we haven't done before, but very, very good practice. Okay, so we've got 20 of these endangered owls with their wingspan measured with X. We've got summary statistics, work out the mean, standard deviation. Okay, something that you should be getting very comfortable doing now. Okay, so our mean is going to be 316 divided by 20. Okay, let's put it in our calculator. 316 divided by 20, we get 15.8. Okay, and I know in quite a lot of my videos I don't put units, kind of always add your units. And then standard deviation, there you go, standard deviation is going to be the square root of 5078 over our n minus our 15.8 squared. Put that all in the calculator at once, so 5078. Break it down if you often find yourself making mistakes. Squared, and that gives us a standard deviation of 2.06 centimeters. Perfect. Of the 20 birds. Yep, nice. Okay. One more bird was caught. Its wingspan was 13 centimeters without doing any further calculations. So you think this will affect the wing range? Okay, perfect. So there's a wingspan of 13 centimeters. Okay, but because we're rounding to the nearest centimeter, it's kind of got this, right? But even in this range, everything, even on the higher bound of it, will be bringing our mean down. Okay, so 13.5 is max it can be. 13.5 is less than our mean, so mean lowered. Okay, an argument that has those kind of points. Okay, now 20 giant ibises, don't know what that is, were also caught for ringing. Their wingspans were that, measured to the nearest centimeter, and now we're doing coding. See? So we've got a summary statistics, mean, and standard deviation. Okay, so let's just figure out. So yeah, they find the mean and standard deviation of these answers, a 5 marker. Right, question 11, it broke this down for us. Now we need to be able to do it ourselves. Okay, so let's find the mean of Z and our kind of standard deviation of Z. So our mean of the coded data, mean of Z, is going to be 104. Were these 20 more again? 20 more? Yeah, 20 more of those. So 104 divided by 20. Perfect, 5.2 centimeters. And then we're going to have our standard deviation of Z is going to be, and what have they given us? SZZ, perfect. So we got the square root of SZZ over n, I forgot what SZZ was, 1.8. Okay, so we got 1.8 divided by SSS. 1.8 divided by 20, sorry. Okay, 0.3. Good, and then square root that as well, I did that in my calculator. Okay, so we found of Z, but Z has been coded and they really want Y. Alright, so Z is Y take away 5 over 10. Okay, and we know that when you code the mean, okay, if you think of this as kind of giving some data, right, coding the mean, if you're adding or subtracting, or if you're timesing, that's all going to affect our mean, right? If you're making every value in our list, 2 times bigger, then that's going to make our mean 2 times bigger. Okay, that seems simple, right? That's quite obvious, but when we look at the standard deviation, that's when that point makes a bit more sense. Okay, so we're rearranging it in terms of y, so we've got 5.2, so 10 times 5.2 plus 5, so we get 57 centimeters. Pretty big wingspan there. Now, when we find standard deviation, okay, we don't care about this adding, we only care about the timesing, right? Because if you had a range of 1 to 10, and then you've added, 2 to both sides, you have 3 to 13, okay, so 3 to 12, you still have the range of 9. Okay, standard deviation is how much it differs away from your mean. Okay, think of it kind of like range. It's not the same thing, but it's about spread of your data. Okay, if you're adding, subtracting, your spread is just it's the same spread, it's just moving left to the right of kind of this scale. Okay, if that doesn't make sense, fine, but or just memorize, we don't add and subtract when we do standard deviation. So we have 10 lots of our previous standard deviation, which is 3 centimeters. Okay, and those are our final two answers.